Hey, Chem30s, Manchak here with another video lesson. This is going to be a video lesson for concept C3. And you'll be happy to know that this concept is relatively short, so that means that getting through it is going to be relatively painless for you, I hope. Um, as of this point, what you should have accomplished is you should have made your way through concepts C1 and C2. Remember, concept C1 is a very straightforward introduction to what organic compounds are, how to recognize them, and what they are not. And concept C2 was much longer and much more involved, and it was your very first introduction to dealing with a new naming system, the IUPAC way of naming organic compounds, as well as drawing their chemical structures. So you should have made your way through concept C2 through alkanes, alkenes, and alkynes, and now you are ready to head into concept C3, which deals with aromatics. So we're adding a little more complexity to the compounds, but what you guys are going to find is that it's relatively simple based on what you've learned in concept C2. If you are not comfortable with concept C2, then please take the time to go back and make sure that you are comfortable with it before you move on to concept C3 and the rest of this unit. Otherwise, you're going to end up with some troubles, I think. So, without any further ado, let's just have a look at what our objectives are for this concept. So we are going to name and draw structural condensed and line diagrams and formulas using the IUPAC nomenclature for our guidelines for, in particular here, aromatic carbon compounds. We're going to talk briefly about the boiling points and solubility of these aromatics, but honestly, we'll jump into this boiling point and solubility stuff a little bit later on with some of the other compounds. And then the thing that I'm going to tack on to the end of this is a bit of a self-directed section of your notes. And you'll notice there's a section for the second half of concept C3 called crude oil refining. I'm going to get you guys to have a look at these processes on your own because honestly the textbook does an excellent job of explaining them and you don't really need me to explain them to you. And I'll attach a video to that as well as we need it. So this is what we're going to be going through and just the notes that I've created for myself, things to highlight. So we'll talk about aromatics and we'll talk about the compound benzene and why it is considered to be an aromatic and what's interesting about it. We'll name and we'll look at the naming and drawing rules, and the great thing is that these are the same rules that you learned in C2. We're just tacking them on to dealing with this benzene ring that you guys are going to learn about. We'll talk about the difference between a phenyl group or a benzene and the differences between that. And then you guys will be doing a self-directed set of notes where you'll be looking at crude oil refining. But I will jump into this briefly in this video lesson just to point out the highlights that I want you guys to get from this. But the bulk of it, it'll mostly just be me saying, hey, make sure you learn this, pay attention to this, that kind of stuff. There's a couple of videos I've associated with this. This video on aromatics and cyclic compounds by Crash Course is absolutely excellent. I would highly recommend you watch it. It's 9 minutes-ish long. I think he does an excellent job explaining what you guys need to know with the illustrations and graphics and stuff. Really, it seems to me the more I look at his stuff, it's great. So, you know, if you need a little bit of brush up on anything, go to Crash Course and have a look at it. The aromatic stuff starts at about 3 minutes. So if you want to skip over the beginning stuff, that's fine. But it's a good review of cyclic aliphatics, so you may want to have a look at that too. And then I always show this video on petroleum refining basics because it gives you an idea of what fractional distillation is, and it becomes our transition into looking at some of the reactions that we're going to look at with these organic compounds, and that'll be coming up in C4, C5, C6, and so on. You guys will have a worksheet to do on aliphatics and aromatics, and I'll reiterate what aliphatics is right now. Remember, aliphatics are all of those carbon and hydrogen-based compounds made up of the alkanes, alkenes, and alkynes. Remember, and aromatics is going to sit outside of that, so that's why I'm making that distinction. And as we get further into concepts C4 and C5, you guys are going to see that we're going to start to add more than just carbon and hydrogen to our organic compounds. Oxygen, some of the halogens are going to come in, etc., etc. You guys will have a formative quiz to do before you go and do the summative quiz. And as always, remember, do the formative quiz first and the worksheet first before you go on to the summative so you don't end up making any mistakes. I'm going to just quickly tab over to our notes, and we will get started with the aromatic stuff. Like I said, this is going to be relatively quick and relatively straightforward because we've already, it's a short concept. Hey, and you've done all of this C2 stuff already. So this should be relatively easy to pick up on. So this is the stuff that I summarized in the right at the beginning of the lesson here. So we're going to skip over that for now, and we're going to jump into talking about benzene and benzene-like structures. So anything that we consider to be aromatic is something that contains this compound benzene in it, or a benzene-like structure. And so before I get any deeper into what aromatics are, let's just have a look at benzene itself. So right here it says aromatics are defined as benzene and all other compounds that contain benzene-like structure and properties. So this over here is benzene, and this would be our expanded structural diagram of benzene. So we've got a carbon, 6 carbons in a cyclical form with alternating double and single bonds. Okay, and then a hydrogen attached to each carbon. So the chemical formula for benzene by itself is C6H6, which is kind of an interesting way to look at things. And benzene's a really unusual molecule. And when you watch the crash course video on this, he does an excellent job of sort of explaining that we really start to see the unusualness of the carbon atom come out in benzene. So I think this is a really interesting way to look at things. I'm going to move my screen for a second so we can see. This is the line diagram that we often use to represent benzene. And that line diagram includes this circle. And why it includes that, and this is really interesting, is that the double and single bonds that you see here aren't always in the same location as each second passes for a benzene molecule. For example, this double bond here may move to here, then moving the single bond here, moving this double bond there, and so on and so on. And so those bonds are ephemeral. They shift within that molecule, and so hence we have this circle going on here that represents that shifting of those bonds as time goes by. I'm not going to guarantee this link works. Probably should have checked it beforehand. It doesn't seem to want to work. It was just a 3D representation of what the benzene molecule would look like. Okay, so I had a little bit of trouble there, so I'm going to try to get this back up and running again for you. So here's where we left off. I said to you that benzene is a bit of an odd structure, and it took a while for chemists to really get an idea of what benzene is all about and how it works and why it behaves the way it does. So it perplexed them for a number of years. And here's some of the things that really made them think, well, this is an odd thing. First, the molecular formula of benzene, based on its composition and molar mass, is C6H6. And so when they did some analysis of this compound, they realized, it is C6H6, which is kind of odd, because it was unlike any other compound that we've seen before. It didn't show any indication of a triple bond. It showed indications of double and single bonds, but they really had trouble trying to determine where that came from. The other thing is the melting points and boiling points of benzene at 5.5 and 8.01 it's a relatively wide range and relatively close to what water is, give or take a little bit. But tests also show that the molecules were nonpolar, and with a relatively high melting point and a relatively high boiling point, you might think that it would have more intermolecular forces, but the data were showing no, it doesn't have more intermolecular forces. It's actually got fewer, which is rather interesting. There's also no empirical evidence for the idea that there are double or triple bonds in benzene. It's really unusual. So when they were testing it, it didn't really show anything. It's very unreactive with hydrogen, for example. And anything with a double or triple bond that they'd found is relatively reactive with small diatomic molecules, where we could break that double or triple bond and open up some bonding electrons and allow for a hydrogen or a chlorine or something to come in. X-ray diffraction indicated that all the carbon-carbon bonds in benzene are the same length, which is interesting. And we haven't really talked about bond length much, and I'm not going to dwell on it too much. But it sort of had to do with some bonds being a little shorter, like double and triple bonds, than a single carbon-carbon single bond. And the last piece of evidence is that evidence from chemical reactions indicate that all carbons in benzene are identical and each carbon is bonded to one hydrogen. And this couldn't be true if it had any double or single bonds in it. So benzene was really unusual for chemists. So they did a lot of tests with it, and finally they came up then with this structure that you see here. These alternating double and single bonds that are actually ephemeral. They stick around a short time and then they switch, but they're still always alternating. It's just that, you know, this double bond ends up here, this double bond ends up here, this double bond ends up here at some point in time. When we are naming and drawing compounds with benzene, we are going to follow the same rules that we did for aliphatic hydrocarbons, so your alkanes, alkenes, and alkynes, and particularly the cyclo versions of these things. So we're going to number the branches in the same way we did to try to make the numbers as small as possible, and then if only one branch is present, we don't need to indicate a number for it. So we're just going to call it methyl benzene. If you imagine this is a dimethyl benzene, but if you imagine that this bond is not, or this branch is not here, then this becomes a methyl benzene. We don't have to say one methyl benzene. We'll just assume that we're going to number the carbon that the branch is attached to as carbon number 1. Because this has two bonds on it, okay, we have to try to make our numbers as low as possible. So our instinct might be to label this as carbon number 1, but that's not going to work for us, because then we're going to have to label 1. Well, we could, I guess. We could label it 1, 2, 3, or we could label it 1, 2, 3, 4, 5, 6. Well, then that makes the numbers 1 and 5. That's too big, but if we can make them 1 and 3, that's even better. So this is a dimethyl benzene, and then if there's two methyls, then we need to identify where they are located on the carbon. Or on the ring in this case. So we're going to label them. We could use this as carbon 1 or this as carbon 1. It doesn't matter. We just have to go in the right direction. I think I'd put this as carbon 1, carbon 2, carbon 3. So we'll call it a 1,3 dimethyl benzene. Okay. I hope that makes sense. What I'm going to do now is hit pause and get set up to show you guys the rest of the examples here on a piece of paper. So just give me a moment, please. Okay, so we're going to jump into some examples here. Benzene rings also become part of other hydrocarbons. So when a benzene becomes part of a larger hydrocarbon, so I guess the way to look at this is we have two versions of the way benzene can be. Benzene can be the parent, or the parent chain in a compound. So like we saw up here, benzene is the parent chain in this compound. Okay, and so this is going to be a something and then benzene as the parent chain. When we get into drawing compounds or situations where benzene is no longer the parent chain, it is a branch on a longer chain, we call the branch that has the benzene in it a phenyl group. Okay, so this compound here that has this benzene ring, and by the way, this is another way you can draw benzene. Instead of doing the circle, we can just do our alternating double and single bonds without showing any carbons and hydrogens. So it's another version of a line diagram for benzene. Anyway, this phenyl group is branching off of a larger alkyl group, or a larger parent chain here. This is an alkane, and it's 1, 2, 3, 4, 5, 6 carbons long on this alkane. So this is a something hexane, right, because there's 6 carbons here, and it's a phenyl group coming off of it. So it is a phenyl hexane, and to be precise, it is a 2-phenyl hexane because the phenyl group is coming off of carbon 2. Remember, wherever there is a terminus or an apex or a point on one of these is a carbon. So there's a carbon here, there's a carbon there, this is a point right here, so there's also a carbon there. Okay, and that carbon is the carbon that's attached to this phenyl group. So I hope this makes sense. This becomes 2-phenyl hexane. Okay, so let's do an example here, and I'm going to switch over. We're going to draw the structure for 1-ethyl. I'm going to write this down: 1-ethyl 2,3-dimethyl benzene. Okay, and I'm going to switch my camera over, and you guys are going to get to see what we're doing with my horrible writing. So we're always going to start with the parent chain. So we're going to start here and work our way backwards. So benzene is the last thing listed, so that is the first thing we're going to draw. There's a benzene ring. I just happen to like to draw mine that way. Okay. It is a dimethyl benzene. So we've got 2 1-carbon groups that we're going to work with here. So a dimethyl benzene. Where are they coming off? They're coming off of carbons 2 and 3. At this point, it doesn't matter where you start with carbon 1, 2, 3, whatever it is. I'm going to say this is carbon 1, 2, 3, 4, 5, and 6. Next time I'll draw a little bit bigger so you guys can actually see that. And then we're going to put a methyl group. Sorry, we've got an ethyl group on carbon 1, so I'll just put that. So remember, that's a carbon there, that's a carbon there. This is just a bond. Okay, and then we have a 2,3-dimethyl. So we'll go there and there. Right, there is our 1-ethyl 2,3-dimethyl benzene. I hope that makes sense. I'll draw this next one a little bit bigger for you, so it's a little bit easier to see. I'm just going to flip her upside onto the other side here, and we'll draw it that way. So let's go look at the next example. The next example is 2,3-dimethyl 3-phenyl octane. Okay, so let me write that down. 2,3-dimethyl 3-phenyl, there's my dog barking, octane. Okay, so right away, I'm seeing on this one that our parent chain is an octane. And so we're still dealing with an aromatic because we have a phenyl right here. But we have an octane for our parent chain. So you can go and write this as a condensed version if you want, and why don't I show an example of that? So 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. Okay, there's our octane. I haven't filled in any hydrogens yet, but I will get to that. I like to number from left to right, so let's call this carbon 1, and this will be carbon 8 over here. And we have a 3-phenyl. So that means that on carbon 1, 2, 3, we have a phenyl group coming out. So you could draw it, if you wanted to do condensed, you could draw it like this. It just becomes a lot more work to do, hang on, 1, 2, 3, 4, 5, and there'll be a C here for 6. Okay, so there is our phenyl group. Oh, and let's put in our alternating double and single bonds. Okay, and then we have a dimethyl, 2,3-dimethyl. So that means I have a methyl group coming off of here at carbon 2, and then also a methyl group coming off here at carbon 3. So we're just about done. The last thing that I want to do is just make sure that I've got the requisite amount of carbons in this compound. So there's got to be 3 more carbons here to give, or 3 more hydrogens, pardon me, here to give the 4 bonds for the carbon. I have 1, 2, 3 bonds already here, so I'm going to put an H there. I have 1, 2, 3, 4 bonds here, so I don't need any H's. I have 2 bonds here, so I need 2 more H's, 2 more H's, 2 more H's, 2 more H's, and then 3 more H's at the end of that. So what we have there is your 2,3-dimethyl 3-phenyl octane. Notice that it's a phenyl group because it's part of a larger parent chain. Still an aromatic because it's got a benzene ring, but just still part of a phenyl group. Okay, let's look at the next example here on this page. So what would be the name for the structure below? I can do that on here and just recreate this quickly. Okay, and then I'll show you guys this in a second. I just have to make sure I get it right. Okay, so we'll go over here. There's our structure. Because the benzene ring is coming off of the end of this hydrocarbon, this is the branch, this is the benzene ring. If for some reason we have this kind of thing going on, okay, and this wasn't part of the examples, but this branch, this benzene ring, is actually in the middle of this compound here, of this chain here. So this would be a phenyl group. But because it's attached to the end of this structure right here, this becomes a benzene. So we'll ignore that for now. So this is a something benzene. Okay. Now remember, there's a carbon here, a carbon here, and a carbon here. So this is actually the bond between this carbon on the benzene and this part of the branch, and then this is a 2-carbon branch. So that makes this an ethyl benzene. Now, do we need to put a number to it? No, because it's the only branch on there, so we would just call this ethyl benzene. Okay, hope that works. I'm going to pop over to, whoops, the wrong page. There we go. And I believe I had, yeah, I think I'm done with the practice stuff. So I'm just going to hit pause and shut the practice stuff down. All right, so all of that is shut down now. So I just wanted to take a couple of seconds to talk about some common aromatics or things that have these benzene rings inside them. So if you've ever had aspirin before, aspirin has a benzene ring in it. Now something I didn't mention, and I should have mentioned, maybe I skipped over it somewhere by accident in here, is that benzene is considered to be a carcinogen, meaning that it, meaning that it has the potential to cause cancer. It has the ability to mutate the cells that it comes into contact with that could cause the creation of a cancerous cell. That's benzene by itself, and maybe some of the derivatives of benzene. So some of the things that are a little bit, that have some of the branches stuck on it or whatever. But you can see that some of these things that we've looked at here, yeah, aspirin doesn't cause cancer that we're aware of, but it has a benzene ring. Well, that's because it's part of something much bigger than benzene. One of the things that you need to be able to do is to be able to identify a complex compound like aspirin as an aromatic. And it's an aromatic because it has a benzene ring in it. Just like vanillin. Vanillin is the compound that gives a vanilla flavor to something or a vanilla odor to it. And so you can see that there's a benzene ring in it with a bunch of other stuff coming off of it that we haven't identified yet. But by looking at these two, you should be able to see that these are aromatics because they contain a benzene ring. The same thing with toluene down here, also known as methylbenzene. Methylbenzene because it's got that one methyl group on it, and it is aromatic as well because you can identify the aromatic ring on it, the benzene ring on it. Okay, so benzene by itself is carcinogenic, and we have to watch out for that. But when benzene becomes part of larger, more complex compounds, that carcinogenic nature often disappears. And so we find things that are out there in our world that we would consume and consider to be healthy or good for us, like aspirin, as something not carcinogenic, even though it has a benzene ring in it. So just to sort of fill in the blanks, we are dealing with hydrocarbons right now, and we're dealing with hydrocarbons because the stuff we've been talking about thus far has only been hydrogens and carbons in the compounds. So we first talked about in C2 alkanes, alkenes, and alkynes, which we defined as aliphatics, including the cyclocompounds in each family. And we are also finishing off our hydrocarbons talking about aromatics because the stuff we've talked about so far has only really had carbon and hydrogen in it, save for these examples up here. what you guys are moving on to right now, and I'd like you to move on to right now, is if you'd like to, you could hit pause at this point and go and do some practice around all of this stuff with the aromatics. Worksheet number 2 would be a great place to look. Maybe watching the crash course video on aromatics and cyclic compounds would be helpful too. If you want to continue on, I'm just going to spend a couple of minutes talking to you about what I want you to do for the next section of notes on C3, which is the self-directed stuff. Really, I want you to go to your textbook at this point. So in your notes, by the way, you'll notice that there are some blanks in this section, and these are fill-in-the-blank self-directed notes where I want you guys to go into the textbook, these pages, 10 pages here, 386 to 396, and start to fill in the blanks. And the really important bits that I want you guys to come up with here: what is fractional distillation, what is solvent extraction, and how do we get basically from crude oil into the stuff that we can actually start to work with and use. So I'm just going to open up. This is a representation of what your textbook stuff looks like. And I'm just going to zoom in a little bit so we can see a little bit better. So this section's called crude oil refining. And it's actually going to talk a little bit about what crude oil is. And I really need you guys to understand that crude oil is basically just a soup of a whole bunch of different lengths of hydrocarbons, most of them relatively simple hydrocarbons that deal with, that come out of the ground. And then what we have to do is when we pull crude oil or bitumen, which is the stuff that comes out of the ground at the oil sands, when we pull it out of the ground, we need to refine it. We need to turn it into something usable for us. And so the first step of that process is this process of fractionation or fractional distillation. And this is what I really want you guys to focus in on for this last half of C3, is really try to get to understand the physical processes of refining oil and how this thing called a fractionation tower works. So this diagram explains what's going on, but I'm going to leave you guys to sort of dig around in your notes a little bit, or dig around in the textbook and add this to your notes about what's going on here and what fractional distillation is all about. Okay, I'd like you guys to really quickly look at cracking, because we'll talk about what cracking is in a little bit later on, and get an understanding that, you know, this is the general process. We take something big and break it into smaller pieces. And you can have a look at catalytic reforming and alkylation. And then the last thing I'm going to point out in the notes here is there's 2 case studies in this section. One on octane number, and then one on the Athabasca oil sands. I'd like you guys just to read through the information on them. I don't really need you to do the questions and submit them to me or anything, but reading through them I think is really important. Okay, so that's what I want you guys to cover for the crude oil refining section. And please watch the video in the resources section of C3 on petroleum refining basics. It's a really good video. I think it comes out of Australia. So they call things a little bit different. They'll call gas, like we would get from the gas station, you know, they'll call it petroleum or petrol. So just be aware the terminology is a little bit different. So that's what I want you guys to cover for the last part of C3. So learn your aromatics at the beginning, learn the how to do the naming and drawing of these compounds, learn how to recognize that something is an aromatic by the aromatic functional group. That's a big term, functional group. The functional group is that benzene ring. If you see something with a benzene ring in it, you're identifying the benzene ring functional group, and you've got yourself an aromatic compound. Okay? For the second half, go through, fill in the blank notes on concept C3 on this stuff related to crude oil refining, and really focus in on this process of fractionation or fractional distillation. Okay, really try to understand that and how we go from this soup of a whole bunch of different hydrocarbons to something that we can actually work with and create things like fuel oils and diesel and all of those kinds of things. So really start to play around with that and try to understand it. Okay, so that is it for concept C3. Relatively short concept for you today. I think I kept it under 30 minutes. As always, if you have any questions, fire me an email, track me down in office hours, and we will talk again really soon when we do concept C4. So I will see you guys later. Stay healthy.